Alright, here are solutions for quiz 7 from Math 65. We're given 4 different trinomials. There's a fourth one down there. And asked to factor them. So what you'll notice is in the first two, my leading coefficient is a 1. There's no number in front of my x squared term. And so what that'll tell me is there's kind of an easier method I can use. In these next two, C and D, my leading coefficient is not a 1. What that'll involve is kind of a more difficult method, or a guess and check method if you prefer to do it that way. So let's get started. When you're dealing with a trinomial whose leading coefficient is a 1, like the case in A and B, it'll always, if it's going to factor, it's always going to factor in a specific form. It's always going to be an x here and an x here. So in fact, I can write that for the answer for both of A and B, if I want to get ahead of myself. And the reason why is if you picture multiplying these binomials back together, it'll be this x times this x, which gives me this x squared right here. Okay, so what about the rest of the terms? How am I going to make sure I end up with the 7x and a 12? Well, there's kind of a trick for that. And the idea is, first, don't worry about the 7x. First, just look at this 12 and come up with a list of factors, they're really integer factors, of the number 12 in this case. In this case, they'll be factors of 6. So what I'm saying is come up with numbers that when you multiply them together you get 12 and focus on the whole numbers, integers. And yeah, they could be, okay, let's come up with the list. 1 times 12, 2 times 6, and 3 times 4. In this specific case, because this 7 is positive, the coefficient on my x term, I only want positive numbers here. But really, negative 1 times negative 12 is also positive 12, so just keep that in mind. And then what you do is you come over here and you look at your 3 different pairs. These all multiply to 12, but in addition to multiplying to 12, they have to add to 7. So if you go over here, the only pair that adds up to positive 7 is 3 and 4. So what that means is I take those numbers and write 1 here and 1 here. And by following this method, what I've managed to do is factor this trinomial. And we can do the same thing down here. Now I want numbers that multiply together to give me 6. Well, 1 and 6 works, or 2 and 3 works, or negative 1 times negative 6, or negative 2 times negative 3. So even though I only wrote 1 times 6 and 2 times 3, think that really these could both be negative. I want the numbers to add up to negative 7 here. I can't get these to add to negative 7, but I could get these to add to negative 7 if instead of using 1 and 6, I use negative 1 and negative 6. So what that's saying is I'll write a negative 1 right here and a negative 6 right here, and I'll have my answer. If you're ever not sure about your answers, you can always check your answers. I could check them by multiplying x minus 1 times x minus 6, for example. A couple ways you can do this, kind of a FOIL method, or if you prefer to set up a box, you can do it with the box method. X times x is x squared. Negative 1 times x is negative 1x. Negative 6 times x is negative 6x. Negative 1 times negative 6 is positive 6. And now what you'll see is when I combine like terms, I have my x squared minus 7x and plus 6. But you don't have to do that check, so I'll leave that off of the written solutions and move on to the next one. So as I kind of mentioned at the start of this video, C and D are a little bit different. For C and D, there's a couple ways you can do it, and I kind of prefer this multiple step method, where in step 1, you find 2 numbers and I want them to add to the coefficient on my x term, so I want them to add to negative 10, and I want them to multiply to the product of the coefficient on my x squared term and my constant term. What I'm saying is 8 times negative 3 is negative 24, so these 2 numbers that I'm searching for better multiply to negative 24. Well, let's see, things that multiply to 24, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Yeah, those don't multiply to negative 24, they will multiply to positive 24. So when I look at this list, what I'm really thinking is, for the numbers I want, one of them's negative, one of them's positive. So -1, positive 24, or +1, negative 24, and so on. So I'm looking at this list, keeping in mind that one of my two numbers will be negative, and then trying to figure out how I can get them to add to -10. No way you can get these to add to -10, but with these you can. And the way you'll do it is you'll make the 2 positive and the 12 negative. Note that these multiply to give me -24, but they add to -10. Now that you found those numbers, you're not done. Kind of up here, you're done once you find those two numbers. Down here, you're not. Down here in step 2, I'm going to replace my -10x with what I just found, positive 2x minus 12x. Plus 2x minus 12x is the same as minus 10x, but by replacing the minus 10x with this, 8x squared plus 2x minus 12x minus 3, I now have 4 terms, and I can do my final step, which is factor by grouping. I'm not quite sure where I'm going to do factoring by grouping. Maybe I can do it up here. So my first group is 8x squared plus 2x. 2x is the greatest common factor between those two. And if I pull out a 2x from 8x squared, I'm left with 4x. If I pull a 2x out from plus 2x, I'm left with just 1. Then you look at your next group, you want to be left with 4x plus 1. In order to be left with 4x plus 1, you better factor out a -3. Note that if you factor out a -3 from these two terms, you're left with positive 4x plus 1. And so now I have two terms, one over here and one over here, and they both have a 4x plus 1 in them. So I can factor out that 4x plus 1, and then all I'm left with is this 2x and this -3. This right here is my final answer. If that went a little too quick for you, I'm going to do that same method one more time down here. The reason I know to do that method on this problem is this problem, leading coefficient is not a 1. Right? Up in A and B, my leading coefficient is a 1. In C and D, it's not. Because it's not, I need to do my 3-step method. Step 1, I want to find two numbers that add to 5 and multiply to -36. Where'd those come from? Here's the 5. -36 is the product of positive 6 and -6. Search for those numbers. Maybe you can list them out over here, or you can just figure it out. 1 times 36, 2 times 18, 3 times 12, 4 times 9, kind of a lot of them, and 6 times 6. But I don't want them to add to positive, or multiply to positive 36. I want them to multiply to -36. So one of the two numbers better be negative. So keeping in mind that one will be negative and one will be positive, you got to think about how you can get them to add up to positive 5. I think these guys will work. If we choose -4 and positive 9, those certainly add to 5 and they multiply to -36. So it looks like I'm good. Step 2, we're going to replace our middle term plus 5x with these guys. What I'm saying is instead of 6x squared plus 5x minus 6, I'm going to write 6x squared minus 4x plus 9x minus 6. -4x plus 9x is the same as plus 5x, so I haven't changed the equation either, any. Still equal, but it's written in a form that I can deal with now because it's got 4 terms I can factor by grouping. From my first group here, the greatest common factor is 2x. If I pull out that 2x, I'm left with 3x minus 2. From this next group, in order to be left with 3x minus 2, what I'm going to have to do is pull out a 3. What I now have are two terms that both have a 3x minus 2 in them. So I can factor out that 3x minus 2, that's this guy and this guy. And all that I have left behind is a 2x and a plus 3. What I've managed to do is factor that polynomial. So that's the end of the quiz. As you see, C and D are quite a bit harder than A and B. But the nice thing is kind of once you learn this method, it's a little bit long of a method. It'll always work on any polynomials where the leading coefficient is not a 1 that factors. We'll learn later in the class what to do on some problems that don't factor. But if it's going to factor, if you're asked to factor it and it looks like this method will always work. Alright, that's the end of this video.